Let us discuss circuit containing capacitor only or a purely capacitive circuit. In this circuit we have a capacitor having capacity C. It is connected to a source of alternating EMF E. Alright, so let the applied alternating EMF be given by E is equal to E naught sine omega t. We call this sum equation 1, right? And we know that whenever there is a capacitor like this, there is a potential drop or a potential difference between the plates. Okay, so this potential difference is denoted by V. Got it? At any instant, the potential difference or the potential drop across the capacitor plates is V, which is equal to Q by C. Okay, so from here we have Q is equal to CV. Okay, call this sum equation 2. At any instant, the applied EMF E is equal to the potential drop V. So therefore equation 2 will become Q is equal to CE. We are replacing V with E. Now we're replacing E with this equation. You have C E naught sine omega t. Understand? Okay, let's call this sum equation 3. So we got the charge. Now that we can find the current. Yes, current in the circuit is I, which is equal to dq dt. Yes or no? So this will basically be d dt of, let us have a look, what was that equation? Q C E naught sine omega t. So differentiation of C E naught sine omega t. Okay, and C E naught here is a constant. I can take it outside. And differentiation of sine, we know very well, that is cos omega t, right? But then there's an omega out here. You will get omega cos omega t. Is it clear here? So I'm going to write this omega in front. Okay, so this will be omega c E naught cos omega t. So that is basically the current. But then we cannot compare the current, or it's more convenient to write in terms of sine. Okay, so here you will have omega c E naught sine omega t is what? It is sine cos omega t is sine omega t plus pi by 2. So let us see when will the current be maximum. This is equation 4. So current is maximum if this part sine omega t plus pi by 2, this is equal to 1. So therefore I max, and this I max is nothing but the peak value I naught is equal to omega c E naught. Okay, let me write it somewhere here. So I naught is equal to E naught divided by 1 by omega c. Okay, we put this inside of a box. Again, let's call this some equation 5. Right, so again here I naught is E naught divided by some quantity. Okay, you cannot put omega c like this because omega c makes no sense. I have to write 1 by omega c. You will see later on that this is nothing but the capacitive reactance. All right. Okay. So let us switch equation 5 in equation 4. So therefore, equation 4 becomes, I is equal to I naught sine omega t plus pi by 2, which is the expression of the current in the circuit. Let's call this equation 6. Got it? Now let us compare again, just like we did before. We compare the circuit current and the applied alternating EMF, this one. Okay, now to make this comparison, let's do one thing. Let's write it down in the next page, just like we have done before. So this is just the explanation part. You don't need to write it in the body of the answer. So I here is I naught sine omega t plus pi by 2, whereas E here is E naught sine omega t. Okay, so how will the graph look like? See, when omega t is 0, then E will be 0. So the current, the EMF will be starting from this point, right? Omega t 0 means right here. The value of E also will be 0. That means this point. So the EMF will be like that, right? That's EMF. Now, this one, see, if omega t is 0, then this will be sine pi by 2, right? Sine pi by 2. So this basically will be equal to I naught sine pi by 2. And what is sine pi by 2? That is 1. So this will be equal to plus I naught. So if omega t is 0 for the current, it will be plus I naught. Plus I naught is somewhere here. Okay, so the current will be starting from here and it will go like this. Understand or not? So that is the meaning. All right. And what about the phasor? Shall we discuss the phasor later? Okay, let's discuss the phasor part later. So you close the bracket out here. Okay, whatever is written in the bracket, you do not need to mix it in the derivation. Got it? And again, let us have a look here. You see this one, there is a plus sign out here, omega t plus pi by 2. Because of this plus sign, it means that the current is leading the EMF. By how much it is leading? By this phase, by a phase of pi by 2. Is this clear? So that is what we are going to write. Comparing what equation? Let's see, equation 6 and equation 1, I think. Let me have a look, confirm. And equation 1, yeah. Comparing 6 with 1. Comparing equation 6 with 1, we see that the current leads because the current is starting from in front, leads the EMF by a phase of pi by 2. Got it? So let us now draw this graph nicely. This is E naught. Okay, and where from I naught is starting from there. So let me name these points first of all. So this point is basically pi. This is 2 pi. Right here in the middle, that will be 90 degree, which is pi by 2. And this is 3 pi by 2. Okay. So for the current, I'm going to use green color. Yes. So this part here is I naught. Got it? So this basically is the plot for current, and this is the plot for the EMF. All right. Now the phasor diagram. Y-axis, x-axis. The EMF is, with respect to the x-axis, is this much. This is E naught already rotating, making an angle omega t with the x-axis. But then what did I say? The current is leading. Yes or no? It leads. Leading. And it's leading by how much? By 90 degree. And remember that it is anti-clockwise. So if it is leading, so the EMF is still is here, the current is already in front. This is the peak value of the current I naught. And by how much it is leading the EMF? By a phase angle of pi by 2. Alright, so if you look at this equation, where is that equation? Let me check. Equation 5. Okay. Now from this equation 5, how is it written? You have I naught is equal to E naught by 1 by omega c. Got it? Now, if you compare this equation with this equation, I is equal to V by R. Okay, there's a very good close similarity between these two. So do you agree or not that this part 1 by omega c, it behaves or is comparable to this, to the resistance? Okay, so the quantity 1 by omega c is called capacitive reactance. Okay, it is denoted by xc. So therefore xc is equal to 1 by omega c. Now what is the physical significance of this capacitive reactance? Just like resistance, called this equation 7, the capacitive reactance is the effective opposition or the effective resistance offered by the inductor to the flow of AC in the circuit. All right, it is the effective opposition offered, or oppositive I wrote, opposition, T-I-O-N, offered by the inductor to the flow, my handwriting is getting bad, writing too fast, to the flow of AC in the circuit. Got it? And because it is similar to the resistance, its SI unit is that of resistance, ohms. Okay, so some important points when it comes to the capacitive reactance. For a DC, for a DC, what is the value of omega for a DC? DC has no frequency, so the value of omega will be 0. So therefore, xc, which is 1 by omega c, this will be what? It will be 1 by 0, which is infinite. Yes or no? What does this mean? A DC is direct current, okay? If you look at the graph of a DC, it is like that. It does not change with time, it is constant with time. If you plot current with time, let's say this is 3 ampere with time, it is change. It doesn't have ripples like this, okay? It doesn't go like a wave like this, just a straight line. So if it is just a straight line like this, it has no frequency, so the frequency will be 0. So for a direct current, omega is 0, so xc is infinite. Now that means that the inductor will offer infinite opposition to the flow of DC. So this means that the inductor blocks a DC. Understand? So it means that the DC, the direct current, cannot pass through an inductor. That's a very important point. Okay. Second, for an AC, omega is not equal to 0. So obviously, since omega is not equal to 0, so this will not be infinite. Got it? So it will not be infinite like this. So in that case, what happened here? Okay, we can do one thing. If for an AC, it is we can write like this, right? We can write. But what is omega? Omega is 2 pi f. See, no? Since angular frequency is 2 pi f times, so that is xc is proportional to 1 by f. Okay, so if you plot the graph of xc with the linear frequency, you will get this kind of a graph. Say I'm plotting xc along the y-axis and frequency along the x-axis, you will get this kind of graph. Exactly here. So these 2 points are often asked in the exam, so I want you to understand this nicely. Thank you.